And the process that we use to solve that, what seems like huge word problem, is what we call linear programming. And like I kind of explained, linear programming uses those constraints that we have in the situation to find maximum and minimum values. A lot of times we'll be looking for maximum profit, like in that example, but we will also find minimum values as well. To kind of get us started, we need to understand the vocabulary used in these types of problems. The first, which I already mentioned, is a constraint. Constraints are the inequalities in your problem. This is not a lesson that you want to sleep through. Just putting that out there for you. So if you look at the picture that we have here, this is our goal for today. This is what you guys are going to end up doing. So you can see in that picture the different inequalities that we have. Each of those inequalities are graphed. Which is why we reviewed and worked on graphing inequalities last time. You can kind of see how when you graph those inequalities, it cuts off a region. Sometimes it's like a little triangle, sometimes it's a quadrilateral like we have here, but that is what we call the feasible region. This is the area bounded by the constraints. So in this case, we have this little quadrilateral. This is our feasible region. What we call our objective function is the function to be maximized or minimized. If you look down at this first example, you are given that function. This is an example of an objective function, and you're going to see in just a minute how we use that to find our maximum and minimum values. And then finally, what we call the corner points. These are just the vertices of the feasible region. They are exactly what they sound like. They are the corners, in this case, of that quadrilateral. So you are going to hear me use these vocabulary terms, so be sure that you understand what I'm referring to, okay? We are going to kind of break this up into different parts, and then at the end, we are going to put it all together, okay? So it tells us in the first two examples that the feasible region for some sort of constraints, we don't know what they are, but that feasible region has those given corner points or vertices. Given these corner points and our objective function, our job is to find the maximum and minimum values. So the way that I typically have you guys do this is with a little chart. So we're going to have in our chart each ordered pair, and again, those are the corner points that we are given. We take the expression from our objective function, and then the last column is where we put our final value. So we're going to take each of these ordered pairs, put them in our table. And then it's really just a matter of substitution, guys. Okay, so you know in an ordered pair, the x-coordinate is first, the y-coordinate is second. So for each of these, we're simply plugging in, for example, 3 for x and 0 for y for the first one. So in the middle, you're just showing that substitution. So 3 times 3 plus 0, which when we simplify that, our value is 9. So we put that final value in that last column. Next one, so now x is 4, y is 3. So again, we're showing that substitution in the middle. And then we are going to simplify. So we have 12 plus 3, which is 15. And then just continuing on. So the next one, x is -1, y is 6. So this gives me -3 plus 6, which is a +3. And then last but not least, x is -4, y is 0. So that's going to give us a value of -12. So then we're just looking at the values that we have after we plugged in our corner points. What's the smallest number? What's the smallest number? Block 1? -12. That is your minimum value. And what is the biggest? 15. That is our maximum. Okay. Questions? Okay so far? Okay, I'm actually going to skip the second example. I was going to have you guys try that on your own, but I want to make sure we don't run out of time for the next examples that we have. So we're going to go ahead and skip down to the next one. Now this is giving us, remember the inequalities. These are what we call the constraints. It's asking us now to actually graph the constraints or the linear inequalities. Then we're going to identify our feasible region. So at this point, it's no different than what we did last time, okay? Graphing the inequalities, finding where they all meet. And then we're just going to identify the corner points. Now, if you look at these first two inequalities, they are both given in standard form. What you are going to find is that many of your inequalities are going to be in standard form. So we are going to graph these using the intercepts. Okay, so back to the first day when we found x and y intercepts, we're going to do that to graph. So if we, actually, we'll do both. Let's do both. So for the first one, let's go ahead and solve this for y. So all we need to do is subtract the x. So that gives us y is less than or equal to -x plus 9. So our y-intercept is 9. And notice that these are all, or equal to. These are all going to be solid lines here. And then we have a slope of -1. So down 1, over 1, and so on. And then you can graph in that line. And we're going to lightly shade that below. Let's go ahead and solve the second inequality for y. So we need to subtract the 2x. And we want y to be positive, so we're going to think about dividing everything by a -1. So this goes back to Allie's question earlier. Remember, when we divide by that -1, we need to flip our inequality. And then we kind of run into a problem. What's our problem here? Okay, I only gave you a graph that's the first quadrant, okay? I didn't give you a graph that makes graphing 2x minus 6 very easy. I did that on purpose, okay? We'll come back to this in just a second. If you look at the last two inequalities, x is greater than or equal to 0 and y is greater than or equal to 0. When you have those two inequalities together, you are bounding yourself to just the first quadrant, because this means you're only working with positive x values. This means you're only working with positive y values. The only quadrant on your coordinate grid where you have all positive x and y values is the first quadrant. So when you see these two together, understand that you are now only in quadrant 1, which is why I gave you that specific graph. Okay, couple different things now. I'm kind of going back here because we still have that one to graph. Couple of different things that we could do. Grab your graphing calculator, and if you don't have one in front of you, just kind of watch up front. Here's what we can do. I'm going to show you a trick that will help you tremendously throughout the year. Take that equation, go to your y equals. I'm going to have to clear out what I have. Go to your y equals, type in your 2x minus 6. Now, instead of hitting the graph button, do you see what it says right above? What does it say right above for UTI people? It should say table. That means if you hit your second button and then graph, it will give you a table of values that are part of your graph. So then you can just take these values, use them to graph that line, plot some points, okay? So you can scroll up and down. So you can see we have negative numbers here. That's not going to be what we want. So look at 3, 0. That is 1 point in the first quadrant that I can plot. Casio people, I'll try to get with you if you aren't finding your table, okay? Did you find it, Grace? You did? How do you get there? We have another point that we can plot 4, 2. So use your calculator to your advantage. We're not asking you to get these expensive calculators for no reason. I am going to have you use it, okay? Trust me. Another point is 5, 4 that you can plot, and so on. 3 points, that's probably sufficient in order for us to graph that line. And then from here, we can see that we have greater than or equal to, so we are going to shade above that line. And we see that our two colors, be careful here, make sure you don't go beyond the X and Y axis. We can see that when we graph these, we have this quadrilateral that is formed. Remember, that is what we call our fusible region. So we've done 2 of 3 things that we were asked. We graphed the inequalities, we identified the feasible region, and that's just a matter of showing your graph. And then we have to identify the corner points. So that's just a matter of kind of making a list here. And again, the corner points are just the corners of, or the vertices of, that quadrilateral. Mitchell, what's one of our corner points?
0, 0.
Sure is. But these don't have to be in any specific order. Cameron, what's another one?
0, 3.
Flip that around. So
3, 0.
yeah, 3, 0. Go left or right first. That's 3, 0. Xavier, what's another one? 5, 4 sure is. And then our last one is up top here at 0, 9. Okay. What questions do we have? Okay, we have just enough time, so now what we're going to do is kind of put it all together. So look at example 4. It says, let's try a complete problem. All right, the first thing that we need to do, again, is graph our inequalities. So if we look at this first one, that's actually, I think, the first one from the last example too. If you subtract x, we have that inequality that we can graph. So y-intercept of 9 again, slope of -1. Tori, Flip, where are we shading that one, hon? Yeah. If we look at our second inequality, we just need to add the x over. So y is less than or equal to x plus 7. So our y-intercept is 7. And our slope is 1, so up 1, over 1. And we can draw in that line. Colin, where am I shading that one? Say that one more time, sorry. Okay. Your shading does not need to be anything beautiful. Mine is definitely not. And then again, you see that x and y is greater than or equal to 0. So again, understand there's not really any graphing you necessarily need to do there. Just understand that that creates a bound, okay? That creates a bound to your feasible region. So we're below that blue line, we're below the red line for our feasible region. And then the corners of that, again, are the corner points. What questions can I answer? Still are not quite done. Okay, so let's list our corner points. Alicia, what is one of them? Yep. Levi, what's another one?
0, 7.
Yep. Megan, what's another one? Yep. And then our last one is over here at 9, 0. So at that point, we go back, set up our chart that we worked on at the beginning. We take that expression from our objective function, put that in the middle, and then just take our corner points that we found, plug them in. So take a couple of minutes for yourself to plug in your 4 corner points, see what maximum and minimum values you come up with, okay? Looks good, guys. Emma, what did you get when you plugged in 0, 0? Yep. Erica, what about for 07? 56. Mitchell, when you plugged in 18, what did you get?
68.
Okay, very good. And then for 90, we should have 36. Okay. Then again, it's just a matter of identifying your smallest and your biggest number. So we see that our minimum value is 0. Our maximum value is 68. All right.